Producing the meat we enjoy takes a lot of resources, from land and water to energy, and it also adds to the planet's carbon footprint. But what if we could enjoy meat without harming our planet? Livestock farming contributes about 14 to 18% of global greenhouse gas emissions, primarily through methane from cattle digestion and nitrous oxide from manure management. Producing meat also requires extensive resources. Nearly 80% of global agricultural land is used for livestock grazing or feed crops, yet it provides less than 20% of the world's calories. As global demand for meat steadily increases, these impacts are expected to grow, placing additional pressure on ecosystems and natural resources. Meeting the world's food needs will require more efficient and sustainable ways to produce meat. Cultured meat begins with a small collection of animal cells, stem or satellite cells, that can self-renew and differentiate into muscle, fat, and connective tissue. These cells are placed in a nutrient-rich growth medium, containing amino acids, sugars, salts, vitamins, and essential growth factors that mimic the animal's natural environment. Inside bioreactors, temperature, pH, oxygen, and nutrient flow are precisely controlled to ensure optimal cell growth. As the cells multiply, they are supported by edible scaffolds made from plant-based or collagen materials, which help organize the cells into muscle fibers and provide texture. Within 2 to 3 weeks, these fibers mature into structured tissue that can be harvested and shaped into products like burgers, nuggets, or fillets. Scientists are refining cell lines, designing energy-efficient bioreactors, and developing serum-free growth media to make the process scalable. Cultured meat can reduce land use by up to 90% and water use by up to 80% compared to conventional farming. Greenhouse gas emissions can drop by as much as 70%, depending on energy sources. Grown in sterile conditions, cultured meat requires no antibiotics, reducing risks of antimicrobial resistance. Its composition can be tailored, for example, to reduce saturated fat or increase omega-3 fatty acids. Despite this progress, challenges remain. Growth media has been costly, though plant-based and synthetic alternatives are emerging. Scaling bioreactors while maintaining optimal conditions require precise nutrient and oxygen management. Consumer awareness and acceptance are critical for adoption. Since 2013, the cost of cultured meat has fallen dramatically, from hundreds of thousands of dollars to under $20 per serving in experimental settings. Singapore became the first country to approve cultured chicken in 2020. In 2023, the FDA and USDA approved cultured chicken for sale in the US, bringing it closer to mainstream markets. Research continues worldwide to improve cell lines, scaffolds, and energy-efficient production methods. Cultured meat provides a pathway to produce real protein with a fraction of the environmental impact. As renewable energy and bioprocessing improve, its carbon footprint will continue to shrink. Cellular agriculture can help feed nearly 10 billion people by 2050 while protecting natural resources. By combining innovation, sustainability, and ethics, cultured meat could become a key part of a resilient, climate-friendly food system. Cultured meat shows that science and innovation can transform the way we feed the world. By producing real meat without large-scale animal farming, we can significantly reduce land and water use, lower greenhouse gas emissions, and protect biodiversity. As research continues and production scales up, cultured meat could complement plant-based foods, making our diets healthier and more sustainable. Every choice we make matters. Supporting sustainable innovations and staying informed helps create a future where people and the planet thrive together. By advancing cultured meat, we aim to tackle the climate crisis with innovative biotechnological solutions. Stay connected via our project website at www.bioshieldproject.com and our social media platforms.